talking about Boundary Bay Wood Debris Removal Project, an overview and lessons learned. And our third speaker is Kyla Rushton, who's speaking about the many faces of a wetland, the Wetland Ecosystem Service Protocol, and how it will transform how we conserve and protect them. We can move to the next slide. So I'm calling in today from the traditional territory of the Lekwungen-speaking peoples, and I feel very fortunate to be living, working, and playing in the lands quite close to Wasanich territory. And I think I spoke, if those were on the webinar last couple of weeks ago, I said I was learning a little bit about the different ways that Wasanich characterize this time of year. And I'm sorry if I'm mispronouncing it, but it's Waselanu, which is moon of the shaker leaves. As the days become colder and traveling and food gathering territory was limited, the winds that came with this moon were signaled to move into the winter village as open seas became dangerous for movement in open boats. I don't know if those of you like to play on the water, but yeah, it's starting to get a little chilly and choppy out there. And today in the coastal areas, we're supposed to be bracing for impact of what is it called? A bomb cyclone or something. So I hope you're all staying cozy where you are. And without further ado, Megan, is there anything else I've missed? Okay.
I don't believe so, no.
Okay, great. So Neil, you're first up if you'd like to share your screen.
Great, thank you. Thanks everyone for coming. And here we go. Screen sharing. Okay. Welcome everyone. So happy to see you all here and present among some really great people as well. Yeah, my presentation is on some of our adventures into the world of low-tech process-based restoration over the last couple of years. I'm Neil Fletcher. I'm Director of Conservation Stewardship with BC Wildlife Federation, and I'm calling to you today on Hamalkam-speaking people's territories here out of Surrey today. Yeah, I wanted to just say that we've been running a wetlands education program with both education and training and restoration projects since 1996. I've been around since for about 14 years of that. Yeah, so I'll just get right into it. Actually, Lynn gave a presentation a long time ago, I remember, talking about how species at risk we're kind of, we have these like sort of pressure points, and definitely in low-lying valley bottom areas, there's a lot of pressure points on a lot of species at risk. Because we're competing for that land with human development as well. And this slide here shows the extent of wetlands that used to be in the Lower Mainland. So parts of where the coastal Douglas fir area is. And I don't have a map of the Victoria area that looks like this, but I'd imagine there'd be a similar storyline. So the light blue is where wetlands used to be, and here we are today, sort of where wetlands still are on the landscape. So I'll just sort of flick between those two to give you a sense of scale and scope of what has been lost on the land base, just in the Lower Mainland. Okay, just to preface this conversation as well, the current state of things. When we're looking at the news recently, there are wildfires that are record-breaking in the last few years, taking out entire communities of British Columbia. We have epic floods that have ravaged parts of our landscape also in the last few years. Snowpack is a lot lower than it used to be. A lot of this can be attributed to climate change. And then we have, widespread drought as well that has been happening, record-breaking in almost all of these. And this can be very dismal for lots of people. Cumulative impacts and climate change really, impacting a lot of what we see in British Columbia. There has been this shift and conversations around nature-based solutions as a solution to support restoring the land base. And this is picking up a lot of speed and interest. There are many systems that are stuck in an intense feedback loop. And all those things I had mentioned before are kind of related to one another in many, many ways, with climate change kind of being an overbearing aspect of that. We also have human-engineered infrastructure that is is placed under immense strain, and this is because we never really used to think of a lot of forest dynamics and flood dynamics, and we tried to build systems that really didn't really consider future potential impacts of how the climate might change, how the floods might get bigger, how the fires might get more intense. Um, and part of that conversation is looking at natural infrastructure, definitely in areas where there's opportunity still to do that. And I just wanted to talk about how beavers play a potential role in our solutions. People have probably heard of biomimicry and the idea that we can learn a lot from nature. Well, they've been fantastic allies and can be fantastic allies. Consider them as ecosystem engineers. They can build dams and canals. They can help, and through those dams and canals, they can store, spread, sink water. They are often considered a keystone species of many habitats across North America. And historically, they've been a really important species. However, as some of you might know, the history of colonization, the history of the fur trade had a really big impact on the population of beavers and their extent on the landscape. And in the 1930s, part of what might have been part of the great drying effect was that beavers were no longer on the landscape to store, sink water as they used to be. This led to incised streams, eroded banks, and really a very unhealthy watershed. There has been growing momentum around low-tech process-based restoration as a natural way of restoring wetlands and streams. This is these are wood-based processes, simple processes. It's called low tech because it's generally done without heavy equipment, where you're adding wood and other materials into structurally starved systems. So one of the tools is what's called Beaver Dam Analogues. So there's been growing interest in this. Beaver Dam Analogues are full spanning obstructions in stream systems to mimic what beavers do to hold water on the landscape and potentially head start stream systems where beavers are no longer present. In addition, another low-tech process-based restoration technique would be called a post-assisted log structure. In comparison to a full spanning obstruction, these are partial spanning obstructions in stream systems that enable more sinuosity in streams. And if you pair these with Beaver Dam analogues, they can actually be where you're recruiting soils to then grade systems downstream of a site. So those are two of the techniques that are often referred to. This is a manual that really grabbed a lot of attention and has been referenced in the literature a lot out of the University of Utah, and has been shared among many people in terms of how do you implement low-tech process-based restoration. The map here is tracking various projects around North America that are utilizing low-tech process-based restoration among dozens of organizations in the US. You can notice here that most of the projects, and this is over about a span of 20 years, have occurred in the United States, a few in Alberta, and nothing here, at least on this screen, is showing anything that's happened in British Columbia. Now, this was the first Beaver Dam analog I had been to, and this was probably 4 years ago. I had a tour of this site, and this is in Howarth Creek in Merritt, BC. And Tom Wilms, who's a professor at Nicola Valley Institute of Technology, gave a tour of this site, and this is the first time I'd seen it. I'd heard a lot about the work happening in the States, but I was also very reluctant to try this type of project, mostly because I didn't think the regulators would let us do this type of work. Damming streams in British Columbia sounds like a showstopper when it comes to salmon habitat. There's a lot of people who are anti-beaver and don't see the value of them. When I came to this site, I saw very little soil disturbance aside from at the dam site itself. a very sort of low risk opportunity, no weeds at the site because there's little soil disturbance, and about a hectare of wetland created behind this dam. I thought this was an amazing opportunity. The other thing that really kind of opened my mind to this is this was a tour led by DFO. Department of Fisheries and Oceans took us to this site to show us what could be done for restoration. That was a partial aha moment for me. The other aha moment was Monica Pearson, who's a restoration ecologist now working for the province, was shopping around this idea of using low-tech process-based restoration in British Columbia and had coined the term 10,000 Wetlands Initiative. She was reaching out to various groups and seeing if there was anybody who'd like to help launch this type of initiative. After coming from this site on this day when I took this photo, I was driving home through the Hope area and I gave Monica a call and I said, I am fully on board. So that was the genesis of the 10,000 Wetlands Initiative. Following that, we put together an application package to BC Salmon Restoration and Innovation Fund and also had some funding already from the province's Watershed Security Fund to really help us launch this 10,000 Wetlands Initiative. What does that mean for us? We are not building 10,000 wetlands. That is a hope and vision for the future of cumulative benefits of many people doing this work. What we wanted to do was install 100 Beaver Dam Analogues in the next 3 years. That was the way we framed it. And there are sort of four pillars. One is to do the installations. Two was to figure out the regulatory process. Three was to advance the science around this to get a better understanding. And four was to build and support a network of groups that are doing this work. And here's an example. So we'd actually gone down to Washington with Ducks Unlimited to sort of learn from them and figure out how they have done the work. There were multiple groups actually trying out what was called the Beaver Restoration Assessment Tool. This is one that Ducks Unlimited had put together, but there's actually multiple groups trying to do this all at the same time in British Columbia. You can go online now, and Ducks has theirs publicly available. What this shows is with where they've done this analysis, streams and their potential to hold beaver dams. That's what this tool shows. We ended up hiring early in our first year of this work, Jen Rogers, that's her on the left there, to lead this project. Jen had just come out of BCIT. She was studying how effective that tool was in identifying sites for restoration for beavers. That was great. We put her to work the first year identifying sites and building partnerships around the province. All those little red triangles are sites she field assessed to determine if they were suitable for beaver-based restoration. We also sent Jen back to the States a couple times to learn about installation and techniques like that. And all the dots that you see on the screen are sites that we pursued. So sites that we said, these are suitable for beaver-based restoration. I mentioned the permitting end. I've been calling this our brute force technique, where we submit a bunch of applications and figure out how the province is going to navigate it for us. Thank you to the province. They had done an amazing job. They supported this in principle. They were just trying to figure out how they're going to really apply this in a system where the legislation wasn't necessarily built to support this. We were also working with multiple other organizations and sharing that knowledge about how we were doing the permitting process. And this all happened in this last year. Other things to consider in terms of regulations, you can't just go in and drop a bunch of logs in the ground. There's lots of planning that goes on ahead of time. Sometimes it involves requests for review from DFO. There might be archaeological concerns. There's also wildlife, fish, and amphibian salvage permits that may be required as well, just to give some examples of some of the permits and information needed. I mentioned the science behind this. We are also looking at the monitoring of these long-term. We worked with Department of Fisheries on Oceans on a playbook for evaluating the success of these beaver-based restoration projects. That includes looking at how the floodplain responds to this, understanding the stream flow dynamics above and below our stream structures. This is work in progress, and we're also connected to a number of universities and also partners who are interested in evaluating the efficacy. Um, Here's one of our sites. This is Oak Creek. This is this year. We got some permits in to do work on a number of streams. You can see they're working away at building a Beaver Dam analog. We use a different technique here, which you first put all the material in and then reinforce it with the vertical posts. Um, I probably don't have too much time to describe it, but here's an example of one of the sites. Generally, you can see there's two Beaver Dam analogs here. So there's one in the foreground, one in the background. Generally, when we're working on a stream system, we're doing multiple sites. These are the 6 sites we worked on this year with various sort of outputs. Last year, we put one Beaver Dam analog in as a demonstration one at Logan Lake with BCIT students. This year, we put 71 Beaver Dam analogs in on 6 stream reaches. So we're almost at our 100 number. If we add in some of our partners, the Chaco Environment, Water, and Sustainability Society, they put in 40 this year. So I mean, among that, we've hit the 100 target collectively. Okay, once you have Beaver Dam analog in the ground, what about the beavers? When are they going to come in? We have been working with Interior Wildlife Rehabilitation Society, and they've started putting together a facility to hold beavers on the land base. In addition to identifying sites where we could be putting Beaver Dam analogs in, there's also sites that Jen was identifying that could accommodate beavers because there's enough food resources there and it was a suitable site for relocation. So we've been working and feeding that information to this group. They're out of Summerland, BC. You can actually watch Beaver Cam. That's 24 hours a day to watch the beavers that are there. There's on the bottom left, there's Jen, one of the best days of her life, releasing a beaver at a beaver site. The other thing, now that you have beavers on the site, the other thing you may need to think about is how do you live with these beavers? Beavers are very productive species. They might get gregarious and a bit adventurous in the way they like to build dams. This is various groups putting in pond levelers to not allow the beavers, to work with the beavers, allow the dams to stay there, but to moderate how much they impound water behind that stream. So living with beaver techniques is a whole other kit and caboodle of like project type of work that needs to happen, and mostly in urban areas where we already have beavers on the land base. There's opportunity. On the left there, you can see that's the installation of a fish passable pond leveler as well. So there's various techniques to work and live with beaver. Okay, I'm almost done. Here's a group of this is the group that is the Trailblazers, a number of different organizations, First Nations, who are leading this work in British Columbia. We are at the forefront with this group doing a lot of this work. This is what I'd call the documented Beaver Dam analog installations. There's been a lot of probably undocumented cases in British Columbia, but these are the ones that are going through the regulatory regime to get these put into the ground. So kudos to any of the partners that are on the call today that might be here. They've been doing some excellent work and really are helping as a whole community trying to figure out how to advance this technique going into the future. And that's it. Thank you very much and looking forward to the question period.
Thank you, Neil. Big round of applause for you. That was really great. And thank you for all the great photos. Amazing. I had no idea. I've learned a lot. Okay, thank you so much. So since time is of the essence, Daniel, you're up next. Seamless. Perfect. Thank you. And you're muted. And just a reminder for those that joined late, we're holding questions to the end, but you can put them in the chat. And you're still showing mute for some reason.
Now can you hear me?
Yeah.
Now I have to find my presentation, which I have. Hold on, I'm going to just reshare all over again. There we go. Is that all good now? Everything's okay?
Yeah.
Okay,
Thanks.
perfect. So hello, everyone. My name's Dan Stewart. I'm presenting today on the ancestral and unceded homelands of the Hunkaminam and Squamish-speaking peoples in Burnaby, where I'm grateful to live, work, and play. and today I'm presenting on the Boundary Bay Wood Debris Removal Project. This occurred in 2023. I'll be giving an overview of the project, including kind of the motivation behind it, and hopefully share some lessons learned that may be of use to others who are looking at similar projects in their neck of the woods. So to get going, let's provide the context for this project. So back in 2022, Ducks Unlimited Canada was awarded funds from the Federal Nature Smart Climate Solutions Fund. It's a bit of a tongue twister. And the unique thing about this fund is that it has these three objectives, but kind of the prevailing objective with it is number one, which is to reduce Canada's greenhouse gas emissions using natural climate solutions. And for myself as a restoration practitioner, I have to admit this was probably the first time that restoration was funded with this as the priority versus something like species at risk or salmon, which are often where funds come from. And so Ducks Unlimited within this said that they were going to restore wetland habitats in the Fraser River estuary, which was pretty vague. And they invited me to come and assist with elements of project management and offer technical expertise. So I'm not a Ducks Unlimited Canada employee. I'm a local consultant and kind of specializing in marsh ecology. And so let's move now into the rationale well, let's start with why exactly did we choose log removal? So when we think of how vague the original idea was in this project of just restoring wetlands, a lot of things could fit under that umbrella. And so we decided to move forward with log removal for a variety of reasons. One of them is that by removing logs from these smothered areas, we would facilitate marsh recovery. And in so doing, as the plants rebound, we'd increase plant matter, sediment accretion, and below ground biomass, all of which are tied into obviously ecological benefits, but carbon sequestration falls in there as well. We also wanted to focus our efforts on tidal marshes because these ecosystems are now renowned as being these highly efficient carbon sinks, especially salt marshes. We had a lot of options to consider, even just restoration projects within tidal marshes. But one of the appealing things about log removal is that it represents one of the cheapest ways to restore tidal marshes. If you compare it, for example, to the act of building and engineering a new tidal marsh, that is far more expensive. And I'd also argue much higher risk. And so given the limitations of our funding, we believed we could maximize our benefits by focusing on this. And this is an obvious one, but we also believe that in removing wood debris, we'd be able to enhance habitat for numerous species that are known to depend on tidal marsh ecosystems to survive, many of which are at risk or culturally significant. So all this sounds good on paper, but log debris removal has not been without controversy in my neck of the woods, as shown by some of these newspaper clips and YouTube articles. And all of these pertain to a project done in 2013 by Port Metro Vancouver in Boundary Bay. And so we wanted to kind of be aware of this going in. We didn't want to just walk into a hornet's nest and find ourselves unprepared. And so I sat through all these YouTube videos, read articles, reached out to many of the opponents of this 2013 project to learn more about, what is at the heart of this opposition. And and these conversations were really, really useful. And through this, we were able to generate a list of points of opposition to log removal. And some of these may resonate with you as you sit through this presentation. So the first thing that we encountered a lot of is the idea that logs are a natural part of marsh ecosystems. So why remove them? The second thing that we came across is the idea that the act of removing the logs will disturb the fragile marsh ecosystem. So we're doing more harm than good by going in there and making a mess of things. The third one was the idea of, well, won't the logs just come back anyways? Which I kind of like to relate to the conversations I have with my kids every time I try to convince them to take a shower or a bath. Won't they just get dirty anyways? Similar logic applies here. And finally, number 4, which doesn't really apply to this project, but certainly applied to that Port Metro Vancouver project, is people were really concerned that removing logs didn't really offset the damages that were occurring elsewhere. So that 2013 project was an offset project related to RBT2, and people called into question just how connected the benefits were of removing logs at this site versus RBT2, which was pretty far away. So that doesn't really apply to this work, and I won't be touching on number 4 anymore. So we wanted to dig into these points of opposition and understand them and be more prepared in our future conversations with stakeholders going forward. And so let's focus first on this idea of logs are a natural part of tidal marsh ecosystems. And, you know, based on historical records, there really is a lot of evidence that wood debris was far more abundant in the Fraser River than what we currently see. We have these quotes like this one from George Vancouver, who was situated somewhere off UBC in the North Arm area there, who said, "The shoal continues along the coast to the distance of 7 or 8 miles from the shore, on which were lodged, and especially before these river openings, logs of wood and stumps of trees innumerable." And then 100 years later, we have this account that says the course of the Fraser is full of dangers and difficulties. The river is as full of snags and sawyers as the Mississippi, which I assume is a lot. Now, in addition to this, we've been dredging the river for quite some time now. And when the river was much shallower, logs that embedded in the 2-meter deep river channel at that time would have been far more obvious and would have obstructed a lot of navigation. Now we're not regularly seeing that. We also have other changes, including the Fraser River debris trap, which you can see in this image on the right, which is situated near Agassiz. And every year, on average, this debris trap pulls 100,000 cubic meters of wood debris that's floating down the Fraser from upriver areas. So this is about 2,000 logging truckloads per year. And in the recent Chilcotin River landslide, apparently about 30,000 cubic meters of wood was removed at that time. So, you know, based on this collective evidence shown on this slide, I think it's really easy to come to the conclusion that, well, maybe we actually live in a wood deficient ecosystem. So what are we doing removing it? But I think there's an important counterpoint here. And one of them is that, you know, is it healthy to base our management on these cryptic quotes of the past? And even if they were clear as day, would they still be applicable in a system that is so heavily modified? Do we have enough habitat for extensive log accumulations that maybe once occurred in the river, especially given all the habitat loss that's occurred, as Neil already touched on? So that's one consideration in this. But another thing is looking at log composition. So 25 years ago, Williams and Cooper went out to several tidal marshes throughout the Fraser Delta, and they found that natural wood debris made up about 50% of the pieces sampled in the estuary, but less than 40% of the overall volume that they sampled. And this is a reminder that a lot of the wood entering these marshes is what we're referring to in this project as anthropogenic wood. It's kind of human origin. And this kind of begs the question of, well, is all wood the same? Is the functional role of a saw log comparable to that of a piece of natural wood 300 years ago? And unfortunately, we don't really have historical images to look back on. But I came across these reports from the Columbia River in the 1850s. And in these reports, it indicated that many of the drift trees at that time were 150 feet long and 13 to 18 feet in circumference. And the largest log they recorded in those surveys was 267 feet long. It's hard to even imagine that now sitting in these marshes. These logs would have been irregular in shape. They would have been full of root wads, branch stumps. They would have been much larger. They would have been less mobile. They would pivot in place. They would scour pools, and they would add heterogeneity to these marshes. They would also provide tall platforms on which woody vegetation would establish, like a nurse log, and perches or nest platforms for birds. The image in the bottom left here was taken from the Skeena this past year, and you can just see how monstrous that log is. But in comparison, you have the logs we see today, the majority of which has been processed into these really small circumference logs that are highly mobile, that function as rolling pins that smother the marsh, that compact the sediments, and offer few ecological benefits. And for this reason, we would argue that human-modified wood should almost be treated separately from natural wood in these conversations. And perhaps it's even fair to say that we have an overabundance of anthropogenic wood in our coastal marshes. But depending on the system or location, we could also have a depletion of natural wood. Both of those things can be true, depending on the watershed. Now, another thing that we wanted to be aware of in this conversation was the idea of the question of, will logs just re-enter sites? That was something we wanted to be aware of. And do sites recover post-log restoration? And to look at recovery, we had the benefit of having sites, previous projects where log removal had occurred in the estuary already. So this location is over in Boundary Bay. This is an aerial photo from the late 1970s. And you can see the extensive log debris in that area at the time. Then in the 1980s, Ducks Unlimited Canada and the province of BC piled up the wood in these areas, 84 hectares of wood debris, and burned it on site, which is a method that's really hard to imagine getting away with nowadays. But this is an example of one of the earliest large-scale log removal projects in the region. Now, the site also underwent log removal again in 2013 by the port. And so we had, at this site, areas of marsh that had never been smothered in recent memory, areas that were smothered in the 80s and were restored, and then areas that were restored twice in the 80s and again in 2013. And this allowed us to kind of get an understanding of the time scale in which it takes for these marshes to recover after log removal. So we collected vegetation data in these areas. And what we found is that there were no significant differences in the amount of coverage of vegetation between these three treatments, although there does appear to be a bit of a time lag, where the areas that were restored most recently appear to be on a trajectory towards achieving kind of coverage similar to the red box plot, but are maybe not quite there yet. So that's something we're just going to have to track over time. We also looked at richness and composition of species present, and we found no significant differences. So we interpreted in this that, despite how messy and impactful these works can be, including burning that was done in the 1980s, marsh recovery can happen in these projects within a decadal timescale, to the point where you wouldn't really know visually that anything had ever happened there when you visit these sites now. Now, we also wanted to address that question of, won't the logs just re-enter? And to do that, we conducted a bunch of historical imagery analyses where we tracked changes in log debris coverage over time in many previous marsh restoration sites. And through this, we were able to calculate the percent increase of log cover over time post-log removal. And what we found with sites is that on average, log reentry averaged about a 1% increase per year. So not a staggering number where all of the works that we did in removing logs would be undone within, say, 5 years or something like that. Yes, logs keep coming back, but it's fairly slow. We were also able to identify through this analysis what kinds of sites were most vulnerable to log reentry. So we found that certain parts of the Fraser Delta were more prone to log reentry, and also sites, certain designs. For example, if a marsh was an embayment, some of these embayments appear to kind of entrap log debris at higher rates than some of the more open areas that are more where logs are more mobile and able to get out. So through this work, we really believed we kind of were able to prepare ourselves for these points of opposition and move forward with this project. So I want to now touch on our site selection process. We had a long list of log removal candidate sites in the Fraser. There are no shortage of sites, let's put it that way. And what we did is we looked at several factors. We looked at nearby log reentry rates. We looked at accessibility for machinery. Our project engineers were good at advocating for this one. And for this reason, we really avoided any boat access only sites. We looked at invasive species, and for this reason, we kind of prioritized salt marsh over some of the upriver brackish and freshwater sites, because salt marshes exclude most of our problematic invasive species in the area. We looked at carbon sequestration rates in literature, pre-existing soil carbon data sets. So there have been some studies already done in the Frasers. So we prioritized areas that were in close proximity so that we could draw inferences from those data sets. And finally, consultations with First Nations, local governments, and naturalist groups. And through this process, we landed on a site located just south of Boundary Bay Airport in Boundary Bay. And this is just to the east of all historic log removal in Boundary Bay. So the area that we worked in was an area where log removal had not occurred previously. So what did these log removal activities look like once we committed to a site? Well, first we conducted baseline monitoring, conducting surveys for Omus audwini, which is an endangered beetle, and the only mainland populations of this beetle in British Columbia occur in the Boundary Bay area. Lots of vegetation sampling. We also calculated wood volume and composition using log surveys. We went out and identified and marked pieces of LWD that we wanted to keep in place. Again, acknowledging that there's some nuance about the value of wood. We're not in here to come in with a vacuum and suck out all wood from the site and make it spotless. We want to acknowledge that wood has a place in these marshes. And so we identified them ahead of time to ensure the excavator operators didn't damage or remove them. And finally, we did a similar process with creosote and contaminated wood, where we were fearful that operators might not see them and might mix them in our wood. And so we went out and flagged them ahead of time. And so this is what it looked like.
Sorry to interrupt. How much more time do you think you're going to need?
Just a couple minutes. Is
Perfect.
that okay?
Okay. Yeah, okay. Thanks.
Yeah, so the excavator operators went out, they pulled in the log debris that you see here, they stacked it near the dike, and then trucks came along the dike and they loaded it. And so this was conducted over 19 days in late January, early March 2023. And so all in all, we restored 1.5 hectares of salt marsh. 48 bin trucks were loaded during this time, and about 950 metric tons of material was removed. Our wood ended up going to 3 different facilities, a biofuel one, a mulching facility, and a creosote disposal facility. And in the end, we kept about 80 pieces of large woody debris. And so this is what the site looked like immediately after restoration. I'll only briefly touch on this, but we planted the site with donor plugs extracted from a nearby marsh, shown by that orange polygon. We also planted nursery stock, and the areas in red we left to be vegetated by just natural colonization, which was the standard practice. And so we continued to monitor this site. We conducted a year of continued beetle sampling to look at the response of beetles in this area. We continue to gather vegetation data and photo monitoring opportunistically. And even after a very 5-month period, we saw that our restored areas were starting to green up quite rapidly. And we were encouraged to see that it's already on that trajectory towards resembling the reference marsh. And so these are some examples of how it greened up. This is only a 5-month difference between the photos being taken. So you can see that the recovery is quite rapid in these sites. And finally, to close, I want to just share a few brief challenges. One of them is that drones were not an option with this project, and that was really due to the proximity of our project to the nearby airport. And this really hindered some of our proposed monitoring methods. Creosote and garbage was a huge headache. Initially, we thought only 5% of our loads would go to the creosote facility, but in the end, 40% went. And this was just due to it being really challenging to sort the material. A lot of the really old creosote was really hard to detect, and it just really escalated project costs and created a huge headache for us. And we'd like to work on that with future projects going forward. And the lessons we learned is that log reentry really varies site to site and should really be considered in future site selection processes. Passive recovery really remains a viable option for restoring salt marshes, and our early data have confirmed that. And we want to remind folks that not all wood needs to go, that large LWD is a good thing, and we don't need to remove it all. So thank you, everyone. Here's our funding and those who helped with the project.
Thanks, Dan. Sorry to rush you.
Okay.
That was amazing, though. Wow, and the lessons learned. Reminder, please hold on to your questions. You can put them in the chat if you like. And Kyla, please share. Thanks.
Yeah. Can you see that?
Yeah, it's great. Thank you so much.
Yeah, thanks for having me. I'm Kyla Rushton. I'm the Wetland Assessment and Field Coordinator with the BC Wildlife Federation. So I work for Neil. I've been here for 3.5 years, working mostly on the Wetland Ecosystem Services Protocol that I'm going to share about today. And I'm joining today from the traditional territory of the Silks Okanagan people in Summerland. They've been working on this project kind of across BC, including down the coast in the coastal Douglas fir. So I'm going to kind of go through what is WESP, some of the wetland functions and benefits that this captures, some site examples of how this can be applied, the process of using this tool, and then the calibration process and some of the next steps for it. So like Neil and Dan have mentioned, wetlands provide many different functions. So things like fire resistance or wildfire breaks in that left picture, pollinator habitat, ungulate habitat, bird habitat, along with lots of hydrological functions like water storage that Neil was mentioning. And in BC, we've lost a lot of wetlands due to land use, draining, diking, and removal. And in BC, we don't have much for standardized tools to quantify the kind of diversity of functions that wetlands are providing, which is becoming more of an issue with loss of wetlands and focus on restoring those or protecting the ones that we still have. So without a tool to kind of quantify the diversity of functions that wetlands provide, we're really limited in supporting decision-making around wetlands. And in BC, we don't have functional assessment tools to help describe the diversity of wetlands or support those decisions that affect wetlands. So neighboring jurisdictions like Alberta, Oregon, Alaska, and the Maritimes all use WESP for the Wetland Ecosystem Services Protocol. And then some other jurisdictions like Washington and Ontario have similar wetland functional assessments. So in 2019, before I worked for BCF, Neil was working with the Skeena Environmental Sustainability Initiative, and they were looking to bring in a tool to support decision-making around wetlands. So Neil was working with the primary author of WESP, Paul Adamus, and worked on bringing WESP into BC in that region. WESP was selected as the tool to be used as it's intended to be completed quite rapidly, so within a day, and allows for one user to collect information that will be used to calculate the relative functions without the person using the tool being an expert in every single function. So a wetland practitioner with minimal expertise on functions like pollinator habitat can complete an assessment, and then another wetland practitioner with expertise in ungulate habitat, they can both complete an assessment and they'll come up with the same estimation of wetland functions and benefits without being an expert in every single one, which is kind of what some other protocols might require. So once you have an idea of how to do the assessment and the questions, you can complete this without being an expert in everything. So what this looks like, there's 45 field indicators that are done when you're on the ground on the site. And then there's 65 GIS calculated indicators. Some of those are scripted. Some of those have to be done by manually inspecting imagery. They go into the WESP calculator, which historically was in Excel, now is in an R package. And then WESP generates scores from 0 to 10 for 16 wetland functions and 17 wetland benefits. So these are things like waterbird habitat, carbon stock, native plant diversity, wetland sensitivity, pollinator habitat, ungulate habitat. The list goes on. Under WESP, these functions and benefits are separated out. So functions are defined as the physical, chemical, and biological processes that are supported by the wetland. So the wetland is doing these functions anyways, regardless of where the wetland occurs. And then the benefits are qualifying the importance of a given function to human society. So based on what that wetland is surrounded by, if it's like right upstream of a community, the benefits might be higher. A wetland that's rated as being really high for fire resistance function. So if it has lots of open water, limited burnable materials, water present for most of the year, it might be really good as a wildfire break. And it would have really high benefit if it's close to a community, but would have lower benefit if it's out amongst a very saturated landscape surrounded by other wetlands. There is kind of an important distinction in wetland function versus condition. So lots of times we think of good wetlands as being fully vegetated and not disturbed. But in the framing of WES, function and condition are not the same thing. So high functioning wetlands are wetlands that are rated as high for performing many functions really well, might not necessarily be of a high condition. So that same wetland could be quite degraded. This wetland on the left has been pretty impacted by logging around it. There's lots of bare ground, potentially invasive species, no buffer between the adjoining forest, and little vegetation or food for wildlife. But this wetland could still be really high in function for water birds, fire resistance, even if it isn't healthy compared to how good that wetland could be. So if we think of its potential being fully vegetated with no invasives and having an intact buffer, etc. And then on the right, a low functioning wetland, hypothetically, overall might not be of low condition. So this peatland that's on a slope with no open water is unlikely to ever score high for things like water storage or sediment retention or waterbird habitat because it doesn't have the open water characteristic or water pooling to allow for those types of habitat. So just because a waterbird isn't going to live here, the wetland could still be pristine as it's ever going to be. So it could have really high condition without necessarily being really high in function. So every wetland really has its different strengths and weaknesses, and WESP is trying to help pull out kind of what the different functions and benefits can be. It's kind of depending on that landscape. So this is just a conceptual option for how the functions and benefits of a site could be illustrated after using WESP on a site. So the left half is all the wetland functions, and then the right half is that same wetlands benefits. And the coloring relates to low, medium, high scoring. So low being red, medium being yellow, and high being green. And then the symbols we had illustrated for each different function and benefit. So that water storage is on the left, and then sediment retention or stream flow and temperature support, sediment retention, phosphorus retention, etc. So in this one, water storage, stream flow, and temperature support and sediment retention are all scoring as medium for functions. And then things like fish habitat and amphibian habitat are scoring as high, but the water bird and ungulate habitat is low. So WESP could be used to be performed on multiple sites and then have these report cards for different sites. And then you could prioritize specific functions or benefits that are interested or that are of interest for that region. So if you were specifically interested in hydrological function like water storage and sediment retention, you could prioritize those in which site you're looking to identify as better than the other site. Or this can be used as a measure for offsetting or mitigation. We'll talk about the next one. So you could complete this on 2 different sites. Say, hypothetically, you're interested in amphibian habitat, water storage, and recreational value. If this left wetland was to be disturbed, you could complete WESP, see how it's scoring for those things, and then potentially offer this wetland on the right as a similar wetland for offsetting. So if you were to protect or enhance this wetland on the right, say the amphibian habitat is high in both, water storage is even better on our potential site, and recreational value is low, but potentially we could increase recreational value by specific modifications to the site. Or you could say this isn't a suitable site because it doesn't score the same for all 3 things. So WESP really just helps provide standardization for how we're discussing the relative value and the functions and benefits. It's not necessarily to say what should be decide to be the most important functions or benefits, but just to give some level of me talking to Dan or Neil or anyone else that we're all talking about function and benefit being the same way, rather than having to point to specific plant communities or species at risk or other metrics to compare different sites. So how do we actually use WESP? So the field assessment is this illustrated manual. Originally, WESP was a 12-page Excel spreadsheet that was really brutal to get through. We had some illustrators help us to make a more user-friendly guide and add visual aids for some of the questions that are more tricky to interpret, like F24 over here. And then we have this companion survey 123 form that you can use on the iPad to complete the assessment and standardize how our data is collected. When we're actually in the field, I always tell field crews we want to visit the inlet, the outlet, and any dominant areas of vegetation. So this is an example of different types of vegetation that we might try to look at within this site, as well as where is the water coming from, where is it going, and this open pool or shallow open water on the right. We do use a drone to scout access. Dan mentioned that on his project being a limitation. We mostly use mini drones, so under 250 grams, so that you don't need a license to fly it, and they can be flown in most areas, although in airports there's specific like height limitations and stuff that sometimes come into play. This is just another kind of example of the way we visit a site. So investigating where the inlet and outlet are, and then the entire perimeter and any dominant areas. We also complete Canadian National Wetland Inventory plots while we're doing WESP. It really lends itself to collecting the same information that we need that goes into WESP. So in those dominant areas of vegetation, we will, illustrations, we'll do a CNWI plot in like these bigger areas that meet the criteria for that project. And then there's this companion desktop GIS component. So we're scripting as many of these questions as possible with human validation where necessary, depending on the data set and where you are. I think this could play out in different ways. If you have really good stream mapping for the region that you're working in, you might not have to do as many manually, but for the most part, they're scripted. In order to use WESP, this is kind of the big caveat, you have to have a calibrated region. So before WESP can be used on a site of interest, you need a calibration data set of about 100 wetlands that captures the diversity of wetlands across an ecologically similar area. So in BC, we're using eco-provinces as that ecologically similar area. And the reason for calibration in each of these regions is that BC is super diverse. We have deserts, we have coastal wetlands, we have peatlands that extend thousands of hectares, a lot of topography. So comparing wetlands, say between the coast, where we have really long growing season and bigger trees and more standing water, isn't really fair to be comparing a wetland function on the coast versus say where I am in the interior, because the potential for wetlands to develop different characteristics that lend themselves to different functions is really different. So by comparing wetlands kind of within the same eco-province, that's how we come up with low, medium, and high rankings within that eco-province rather than within the whole province. The process of creating our calibration data set is that we first create a base wetlands layer. So we've merged wetlands from Vegetation Resources Inventory or VRI and the Freshwater Atlas wetlands layer. And then we add attributes to every single wetland in an automated process, but using these different criteria. So things like different BEC zones, disturbance types, so whether it's logging or agriculture or roads or whatever, land cover types, so deciduous, coniferous, shrubland, etc. Hydrological characteristics, so if it's adjoining a lake or a river or different streams, and then the size of the wetland and adjoining water bodies. And we set targets for each of these criteria. So we want 5 to 11 of every different type of BEC grouping or different type of disturbance. And then we randomly draw 100 sites in an automated process. And this is to capture like the diversity of wetlands within that region. We don't want the average, we want to capture like the highest and lowest functioning. And this is kind of the best way that we can do this with the available spatial data in BC. So Once we have our 100 wetlands, we also, especially in the Georgia Depression, have to consider land ownership and road access. Then we go through manually and review if we can access the sites that have been drawn. Lots of times we have to substitute out similar sites by looking at the attributes of why that site was drawn. Can we find a similar one? And then working with First Nations, I haven't talked about this a ton, but in every eco province, we've been working with the local First Nations and doing training while we're assessing those sites. And we're limited to mapped wetlands, like those that have worked with the Freshwater Atlas or tried to derive where there's a mapped wetland. Sometimes we go to a mapped wetland and it's a Walmart parking lot, and lots of times we go to outside of a mapped wetland where we expect it to be upland and it's still wetland for like dozens more hectares. So those are kind of the limitations of the calibration. Oops. And calibration in the Georgia Depression was quite difficult with the large amounts of private land. Like the privately managed forest on the island is so different compared to other eco provinces, and trying to capture kind of what's going on in that zone. So you can see these are the sites that we ended up sampling based on where we could get road access and land ownership. And benefit of working in the Georgia Depression was that we had a lot of conservation partners. So Ducks Unlimited Canada had a field crew with us in 2021 that helped collect calibration site data, Nature Trust of BC, amongst others. So that was really helpful in getting more spatial coverage and being able to work with a variety of partners while collecting that calibration data set. I should also mention we chose to focus on non-tidal wetlands. So there is a WESP adapted for tidal wetlands, and we started working on that in 2021, but the extent of that being implemented in other jurisdictions is quite limited. So there was limited guidance for some of the questions, and we found the mapping of where we could actually bank on there being tidal wetlands was quite limited. So we would go to somewhere that we thought would be a tidal wetland, and we'd find a berm or like a dike or some region that it wasn't actually tidal. So we were spending a lot of time trying to get to unique tidal wetlands and then finding out that they were not actually influenced by the tide anymore. So for this reason, we've kind of focused on the non-tidal protocol. I'm just about done. I have like one more slide, but subject matter expert review is something that we're currently working on. We'll be working on in 2025 as well. So working with a set of experts, reviewing what goes into every function and making sure that we're using the best available data sets in BC. And then possible applications. So once WESP is calibrated across the province, the Georgia Depression is done, calibration theoretically, but the application kind of varies and is still being kind of developed, and we're working with the province on this. So the applications in other regions also varies, and how it's implemented in regulation. The possible applications in BC are really standardizing how we're referring to wetland functions and benefits, potentially mitigation or offsetting. So making sure that you're replacing specific functions with the same functions or better functions, and considering this in compensation rates. Protection, so scoring or ranking sites to consider making sure that you're capturing the best sites for acquisition or conservation purposes. Identifying how alterations may impact wetland function by looking at what goes into how each function is calculated and what the major drivers are. Buffer calculations or other applications that really just need a functional measurement, such as economic evaluations. That's kind of it for me. I'll pass it back to Lynn, and then